In this question, we are considering the same reaction again, and at the same temperature, although that's a detail that hasn't made it into the question itself. The initial concentration of the nitrogen dioxide is this time 0.250 molar, and at equilibrium the concentration of the dinitrogen tetroxide is measured to be 0.0133 moles per liter. Now the question breaks this up into an A and a B. Initially we're asked just to calculate the equilibrium concentration of nitrogen dioxide, and then we're asked to calculate KEQ. It's important not to allow that to throw you, because calculating the equilibrium concentration of nitrogen dioxide was something that you were going to have to do anyway in order to be able to find KEQ. And so the solution looks like this. First of all, we draw an ice table from our balanced equation, including our initial concentrations, the change in our concentration. Note in this case, we are making the assumption that our equilibrium will proceed to the right again, because I'm starting initially with reactant and no product. So that's a decent assumption that I'm entitled to make. And then from there, I start in the usual way of solving for x. Now from x, I can put that value back into the expression for the equilibrium concentration of nitrogen dioxide and find its equilibrium concentration. And that is part A of this question solved. Using this information, I can then go on to find the equilibrium constant for this reaction at this temperature, because I now have the equilibrium concentrations of both the nitrogen dioxide and the dinitrogen tetroxide. So I substitute those values into the equilibrium constant expression, and I end up with an answer to three significant figures of 0.272. That's the same value that we saw in the previous question, in question number 2, because it is the same system and at the same temperature. We're just approaching it from a different direction. So KEQ should be the same.